So let's talk about what it means if two triangles are congruent. You all tell me, what does it mean if two triangles are congruent? Excellent. If two triangles are congruent, there was a word I kept using last class. It started with a C. Does anybody remember about the sides and angles that match up? What do we call those? No? Oh. Corresponding. So the corresponding, if two triangles are congruent, the corresponding sides are congruent and the corresponding angles are congruent. So right now, if we have a proof, if we're able to prove the triangle's congruent, do you think after we prove the triangle's congruent, we would be able to say that any pair of sides that correspond are also congruent and any pair of angles that correspond are also congruent? Yeah, so that's where we're starting today. In proofs after we prove triangles congruent, we will be allowed to say that any pair of corresponding angles will be congruent and any pair of corresponding sides will be congruent. And the way we're going to write that in proofs is by writing C as the reason CPCTC, CPCTC. Now, I will tell you this, on the test, I will ask you, or the quiz, I should say, on the quiz that we're having on Friday, I will ask you, what does CPCTC stand for? CPCTC stands for corresponding parts of congruent triangles are congruent. So CPCTC stands for corresponding parts of congruent triangles are congruent. CPCTC. You will never be allowed to prove triangles congruent by CPCTC. CPCTC is not a method to prove triangles congruent. And you will never be allowed to use CPCTC before, Lauren, you prove triangles congruent. All right, CPCTC is always used after you prove triangles congruent. All right, now let's talk about circles. Before I go into fill in any of these blanks, let's just have a little quick discussion. Circles are pretty special because you have one main point that's the center point, but then you have a whole bunch of points around that center point. That's not a very good circle, but you get the idea. Does anybody know what's so special about the distance from the center to any of those points that would be like on the rim of the circle? Sean?
All the points are the same distance from the center.
Exactly. All those points are the same distance from the center. Does anybody know what those segments are called? The segments from the center to the rim of the circle?
The radius?
The radius, exactly. One is a radius, plural, or radii. So basically, any segment from the center to the rim of the circle, they're going to be the same distance, which means all these radii, the segments, the actual segments created from the center to the rim are congruent. They're all the same length. So that brings us to a theorem. And we're working our way up now. The theorem that you have to memorize is radii of a circle are congruent. Right, this is not def of radii. The definition of a radius is a segment from the center to the rim of the circle. That's the definition of the radii. This is a theorem saying all radii are congruent. It means all those radii are the same length. All right, let's go back up here. All right, a circle is named by its center point. The circle that we have to the right over here would be named circle P. The way we shortcut that is you draw a circle with a center point in it, and then you put the letter of the center point. So this is center P. The radius of a circle is a segment from the center to the rim of the circle. Are we ready to do proofs? Yeah, we all got these notes down? Okay. Our first sample problem. Nothing is different. We go through our given, we make conclusions. Now we just have more knowledge. We just keep building on our conclusions knowledge. That's what's happening every day. We're just adding more to the bank. So step one is always to write out our given. In class, I do not write it out. On a test or quiz, do you write it out? Yes, absolutely, you write it out. All right, so the first given is circle P. This might not seem like it's very helpful, but it really is. The fact that I'm giving you circle P, that means I'm identifying the center of the circle. If I'm able to identify the center of the circle, what else am I able to identify?
All the radiuses are the same.
Radii. We're able to identify the radii, exactly. So looking at our diagram right now, which segments are radii? Which segments are radii? Selena?
Segment C, segment D, segment A, and segment B.
So we name a segment with 2 points.
Oh.
2 letters.
Segment CB. Wait, actually, I don't know.
So which point is our center?
Segment P.
Point P is our center. So then it's going from the center to the rim. So segment PC is a radius. Name me another one.
Segment PD.
Excellent. What else?
PA and PD.
Perfect, you got it. So now we're going to be able to say, since all those are radii, since we know the center of the circle, can I say that they're all congruent? So we're going to say segment CP is congruent to segment DP, which is congruent to segment AP, which is congruent to segment BP. We're going to write that out. CP is congruent to DP, which is congruent to AP, which is congruent to BP. And our reason for this is going to be the theorem I just wrote down for you. Radii of a circle are congruent. So I've gone through my given. I've made as many conclusions as I can from the given information. So now I want to prove that segment AB is congruent to segment CD. Would I also be able to say that segment AB is congruent to segment CD because all radii of a circle are congruent? Why not, Lucas?
Because you said that you can't prove that the radii of the circle are congruent. You can't prove it with congruency.
No, I'm saying, like, why can't, like, just like I said, PC is congruent to PB, which is congruent to PD. Why can't I also say A, B, and CD are congruent because radii of a circle are congruent? Why can't that be my reason that they're congruent?
It's not connected to P.
Exactly, because they're not radii. How do we know they're not radii? Because they're not connected to the center point. So these are not radii, therefore we cannot say that they're congruent because they're radii. All right, so we agree they're not congruent, but do we see 2 triangles here? Are these sides of the 2 triangles? So if we were able to prove the triangle's congruent, would we then be able to say because the triangles are congruent that these 2 segments are congruent? Yeah, this is going to be your new game plan moving forward. You go through your given, you make conclusions, and then if you still don't have enough to say what you want to say, you prove triangles congruent. This is going to be an ongoing theme for the majority of the year. Prove triangles congruent, prove triangles congruent, prove triangles congruent. All right, so we have 3 ways to prove triangles congruent at the moment. What are the 3 ways we know to prove triangles congruent? Go on.
Side angle, side.
Side angle, side is 1. Good. What's another one?
Angle, side, angle.
Angle, side, angle. One more.
And side, side, side.
Side, side, side. All right, these are the 3 ways. Do we agree we have 2 sides right now? All right, SS is not enough. I need something else. Does anybody see what else we can say here to prove these triangles congruent? Sienna.
You could do side, angle, side because they have congruent angles where like P is.
Good. We have 2 congruent angles where P is. I'll call them 1 and 2. What kinds of angles are those, Sienna?
Vertical angle.
Vertical angles. So I'm going to say angle 1 is congruent to angle 2. Is the reason def of vertical angle, is that the correct reason here? No, that's not the definition. What is the reason here?
Vertical angles are congruent.
Vertical angles are congruent. All right, so now we can go ahead and I can say triangle CPD. Match it up for me. I said triangle CPD. What are you going to say? Only one person? We're just matching it up, making sure we're putting down the right points. Zia?
APB.
You got it, APB. And that's going to be SAS. Now, after we prove the triangle's congruent, then we can go on and say any pair of corresponding sides are congruent or any pair of corresponding angles are congruent. So we can now say that AB is congruent to CD. Who remembers the reason for this? Why can we say that these are congruent? Just a bunch of letters.
CPCTC.
You got it, CPCTC. Anybody remember what that stands for? CPCTC?
Corresponding points.
Not points, you're right with corresponding.
Parts of congruent triangles.
Good, corresponding parts of congruent triangles are congruent. All right, let's do the next one. Once again, I see circle O. When I see circle O, I know that we're going to need to write down in our proof at some point radii of a circle are congruent. There's no reason to be given a circle if we're not going to be using their radii. All right, so we know we're going to say radii of a circle are congruent. We're going to keep that in our head. Let's see what else they're telling us. They're telling us angle T is a complement to angle MOT. I'm going to put angle 1 here. So we're going to say angle T star, angle 1 star. Then we have angle S is a complement to angle POS, which I'm going to call angle POS angle 2. So I'm going to put a dot on S and a dot on 2. Now, what is it that we want to prove? We want to prove that MO and PO are congruent. Well, it did tell us circle O. So O is the center of the circle. Would I be allowed to say that OM is or MO is congruent to PO and our reason be radii of a circle are congruent? How many people say yes, you can say that? Raise your hand. MO congruent to PO, radii of a circle are congruent. No. Why not? It's coming from the center. Why can't I say it? O is the center.
Because radii is like on the perimeter of the circle.
It's on the rim, exactly. So it comes from the center and it has to go to the rim of the circle. MO and PO are not congruent. Since we're not able to prove what we want from the given information, what do we have to do? Which is going to be the ongoing theme. When we can't prove what we want from the given, we have to prove what? Ever triangles congruent. When we can't prove what we want from the given information, we have to prove triangles congruent. Do we all agree that the triangles we want to prove would have to be MTO and PSO? All right. So now go back. Remember we said we're going to have to use radii are congruent? Does anybody see segments that are part of these triangles but that are also radii? Segments that are parts of the full sides of the triangle but also full radii? No, Dylan? No? Lauren?
TO and SO.
You got it. TO and SO are congruent. So I'm going to say TO is congruent to SO, and the reason is going to be radii of a circle are congruent. That's just a side. Does anybody see anything else we can say? So we just have a side right now. That's it. Lucas?
Angle 1's congruent to angle 2.
Excellent. We can say angle 1's congruent to angle 2. Why, Lucas?
Vertical angles are congruent.
Perfect. Angle 1 is congruent to angle 2. Vertical angles are congruent. Okay, so now we have an angle and a side. That's not enough. An S and an A, or an A and an S, just that alone is not enough. But let's look here. That angle 1 congruent to angle 2 was actually a game changer for us. Because not only is 1 congruent to 2, but 1 is a complement to T, and 2 is a complement to S. Didn't we learn a theorem about angles and their congruent complements? What did that theorem say? Alex?
Complements of congruent angles are congruent.
Excellent. Complements of congruent angles are congruent. So we can go on and we can say angle T is congruent to angle S. And the reason is comps of congruent angles are congruent. Now can we say the triangles are congruent? Yes. Now I can say triangle MTO. I said triangle MTO. Who can match it up for me? I will be checking on the quiz that you do match up the corresponding sides and angles when you write out your triangles properly. So I said MTO. Dylan? PSO. Perfect. And what is the reason for this? What is the reason that they're congruent? Zia? ASA. All right, now that the triangles are finally congruent, now can I say that MO is congruent to PO? Yeah, now we can say that segment MO is congruent to segment PO. What's the reason for that? Good, Lauren, say it.
CPCTC.
You got it, CPCTC. Who remembers what CPCTC stands for? Does it stand for Lucas?
Corresponding parts of congruent triangles are congruent.
Excellent. Corresponding parts of congruent triangles are congruent. Will I ask you that on the quiz? Yes. All right, number 3. Number 3 is definitely more involved. In my opinion, it's a great test or quiz question. Let's see what we got going on over here. All right, let's go through and mark out what we have. So I have that AE is congruent to FC. Then we have that FB is congruent to DE. Is it important that you mark your diagrams correctly? Absolutely. Now we have angle CFB. I'm going to call this angle 3. Is congruent to angle AED, which I'm going to call angle 4. Now we want to prove angle 1 is congruent to angle 2. We went through all the given. There were no conclusions to make directly from this given. So now let's look. We want to prove angle 1 congruent to angle 2. There's absolutely no reason that we are able to say angle 1 and angle 2 are congruent as of right now. So when we're not able to prove what we want from the given information, what is the ongoing theme? Prove triangles congruent. Does anybody see a pair of triangles that have angle 1 and angle 2 in them? Yeah, which triangles have angle 1 and angle 2? What are the two triangles we're going to prove congruent? Euripides?
AFB.
You got it. Triangle AFB, this triangle, I want to prove. Now, the different colors really helps, in my opinion, to triangle CED, this blue triangle. All right, so we want to prove these two triangles congruent. As of right now, based on the given information, DE congruent to BF. Is that a full side? DE and FB? Yeah, DE is a full side of the blue triangle. BF is a full side of the yellow triangle. That's one side. AE, is that a full side of the yellow triangle? No. Is FC a full side of the blue triangle? No. I need to make it a full side. So I don't really want AE. What do I need? I need AF. I need AF. And I don't really want FC. What do I want? CE. I need CE. Does anybody know how we're going to get AF congruent to CE? Alex?
By adding EF to both.
Exactly. So right now, to get from AE to AF, wouldn't I have to add EF to it? And to get from CF to CE, wouldn't I again have to add EF to it? So because I have to add that EF twice, does anybody remember that step in the middle that I have to state? Cameron? Reflexive, you got it. So we're going to say EF congruent to EF reflexive. And that's just letting the reader know that I'm using this twice. And then we can go on and say AF is congruent to CE addition. Okay, so now let's keep going. We have two sides. Looking at our yellow triangle and our blue triangle, we now have two sides. 3 and 4, how come those don't count as angles in our blue and yellow triangles? 3 and 4, how come they do not count as angles for us? Exactly, they're not in the triangles that we're trying to prove. But stay with me right now. I'm just going to erase this marking over here because it's getting in the way of my next angles. Okay, so let's go ahead and call this angle 5 and this angle 6. Is angle 5 in the yellow triangle? Yeah. Is angle 6 in the yellow triangle? Yes. 3 and 4 can absolutely help us get 5 and 6. Anybody know how 3 and 4 are going to help us get 5 and 6? Only 2 people, 3 people? 4 people, 5 people, 6 people, good, 7 people. Alexa, how?
They're supplements.
Exactly, they are supplements. Hey, I no longer have to declare the straight angles, but I still do have to declare the supplement. So I'm going to say angle 3 is a supplement to angle 5, and angle 4 is a supplement to angle 6. What's the reason that we're putting these are supplements? What's the reason for this? Sienna. Depth of stop, you got it. And now, since we declared them supplements, now I can go on and say angle 5 is congruent to angle 6 Who thinks they know the reason for this? Selena? It's not transitive. No, it was one of those 4 theorems I made you memorize.
Congruent angles.
Excellent. Subs of congruent angles are congruent. Do we now have enough to prove these triangles congruent? Yeah, that was a lot. So now we're going to go on and we're going to say triangle DEC is congruent to triangle BFA. What's the method now? What's the reason that they're congruent? Dylan? Side angle side. Now, after we prove the triangle's congruent, now we can say angle 1's congruent to angle 2. What's the reason that angle 1's congruent to angle 2? Zia? CPCTC, you got it. All right, we have 2 independents. I'm going to stop recording now.